Hi everyone. Today we are going to talk about atomic structure. So this is sort of be the first part of a two-part concept here. This is going to be lesson 2.4 here. Lesson 2.4. Okay. So right away here, electrons are arranged in specific regions of space around the nucleus, and these are called orbitals, okay? Now, each atom has different levels or shells that electrons can occupy. These are called principal energy levels. So as we see here, we've got 7 principal energy levels here, 1 through 7, and these correspond to the periods on the periodic table. That's why there's 7 here. So these principal energy levels, they increase in energy as we move out. So n equals 1 is going to be our lowest energy level, and then as energy increases, it's going to go up to 7 there, up to the 7th principal energy level. Okay, now, Okay, now each principal energy level may contain up to 4 smaller regions within called sublevels. So there's a lot of vocabulary that we kind of need to deal with today first before we get into the nitty-gritty of this concept here. So each principal energy level contains up to 4 smaller regions. These are sublevels, and they are S, P, D, and F. And they reference their shape here. So if we look at this diagram, you don't need to copy this down, of course, but this would be our S, our P, our D, and our F here. Okay, so these are our sublevels, and these are what they look like, the shape. So S, we've got this spherical shape here. P, you've got kind of like these lobes like that. And then D and F, they start looking weird. They're looked weird. Okay, so within each sublevel, there are a certain number of orbitals. So S, if we look at S here, only has 1 orbital. Remember, this is S, P, D, and F here. P has 3 orbitals here. So we've got PX, PY, and PZ. And then we've got D, which, oh geez, that's a typo. Sorry guys, that's not 4, that's 5. Has 5 orbitals here. So I've got 1, 2, 3, 4, 5, and they're DZ. They're kind of weird names, and I'll give you a handout for these diagrams here. And then F has 7 orbitals here. So the sublevels all have different numbers of orbitals. Now, each orbital within that contains a maximum of 2 electrons. And the maximum number of orbitals related to each principal energy level is n equals 2. So this will make more sense as we go. So just write this down for now, and that will make more sense once we really get into this stuff here, which will be next lesson. So if we look here, energy level equals n squared. So for example, n equals 2. So if the second principal energy level is 2, 2 squared of course is 4. And if you count them, we've got 4 orbitals here. We've got 1 from the S, and remember P's have 3 orbital levels, so being a total of 4. Okay, so that's where that's coming from, but we'll talk more about that later. So when determining an atom's electron configuration, so that's what our next lesson is going to be. So it will really show where all the electrons are located in an atom. So we need to take 3 rules into consideration when we do that. The first one is called the Aufbau principle. So what this is that electrons will always fill the lowest energy orbitals first. So there's a certain order that electrons will fill in, and they always go low energy first. So again, we'll learn more about this order later, but the first one here is 1s, and then we go 2s, and then 2p, and then we increase energy, okay? So as it goes up, they're increasing in energy. So the lower energy orbitals get filled first. That's the key to this. So remember, there's 2 electrons in an orbital here, so we've got 2 electrons filled here, another 2, 6 here, another 2, another 6, etc., etc. Now, second rule we need to worry about is the Pauli exclusion principle. So electrons spin as they move. So basically we think of there as being two different types of spin. We've got an up spin and a down spin. So an orbital we know that it can contain two electrons, but they must have opposite spins. So you will never have, for example, you will never have this where you've got two up spins. You will never have two downward spins. You will always have one going up and one going down. Okay, so they will always have opposite spins. Now the third rule is Hund's rule. So this is where electrons, we know that they're negatively charged. And what we know about negative charges or like charges is that they're going to repel each other. Oh, got an announcement.
Mr. Quintana, please contact
Anyways.
the Maples office. Mr. Quintana,
Okay.
please contact the Maples office.
In any sublevel, each orbital will receive one electron of all the same spin before any orbital will receive a second electron of the opposite spin. So I'm going to show you the wrong case here first. I'm going to look at this one here. So we've got lowest energy first, so the 1s fills, and then the 2s. And these are going one up, one down, which is good. But then we go to the 2p, and what this is showing is you've got one up, but then we went back and did one down, and that is wrong. So we would have to do one in each orbital before we start filling in the other spin down ones, okay? Let me just erase those. So always spin in one direction first, and then we can go in the opposite direction. Okay, so your assignment for today is the questions on atomic orbitals, so just read them pretty carefully. The answer key will be posted, and then next lesson we'll really get into this electron structure, and some of that stuff will make a lot more sense after tomorrow's lesson. Thanks, everyone.